Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to be creating some 3D printed hinges in Plasticity. Now, we're going to be using version 24.1.6. Any of the 24 versions, and probably quite a bit older, will be fine. In the studio version, it's not really going to matter. Now, if you are looking to purchase Plasticity, then we are an affiliate. You can use the code LEAD10 at checkout, and that'll get 10% off and also helps the channel out. The first step that we want to do is we want to make sure that we're using the millimeter units. Now, if you want to work in inches or something else, that's perfectly fine. But for me, it just makes it quite a bit easier to use millimeters. What we're going to be looking at is two different variations of a 3D printed hinge. Now, this is one type of hinge that you can 3D print. There are, of course, tons of different ones. But I did have the request for print in place. I'm going to talk about the differences that we're going to have to sort of factor in here and why I prefer not to do print in place hinges. But to get started, let's get rid of this cube. We're going to start by using the number 3 on the numpad. So that's going to go to a right view. If you're working on a laptop and you don't have that, just make sure that you click on X on the cube in the upper right hand. And then we're going to start with a circle. Now, the size of this is going to have an impact. So keep that in mind if you're trying to make small hinges, that you are going to have to make some adjustments here. What we're going to do for this video to make it a bit easier is we're going to use a 10 millimeter diameter. So the 10 millimeter diameter, just hit tab and type in 10 and hit enter, then use the / to zoom into it. The reason that we're going to use 10 millimeters is it's a fairly good size. It's not too small when you're 3D printing, and it's not too large. As these hinges get larger, they get a bit easier. As they get smaller, they get more difficult. We'll talk about all that in just a moment, but the first thing that I want to do while it's still selected is use Move. You can use G on the keyboard, and then Z to move in the Z direction, and we're going to move up 5 millimeters and hit Enter, and then sort of bring this back into view. Now, the main reason for this is because I like to assume the x-axis in this case, or really the xy plane, is going to be the build plate for my 3D printer. That makes it a little bit easier when we start snapping to the x-axis and we start designing all of our parts. And we're not going to be making a box or any sort of object for this. We're only going to be doing the hinge in this video. You can, of course, apply it to whatever you are doing. But for our purposes, we're just going to make the hinge. The next thing that I want to do is take a line. I'm going to go from this bottom intersection point and start to drag out to the left. I'm going to make this 20 millimeters. It's probably a bit bigger than it needs to be, but that's just a part that's big enough that we can hold it in hand and then we can kind of see what's happening with the hinge. Then I'm going to start another line. I'm going to come up, find the middle point of the circle, tap Shift to get my sort of projection lines. And then we're going to go to this midpoint intersection here, right click to accept. I'm going to select this bottom edge and join those together with J. Now, anytime we've got multiple profiles like this, if they're visible, we can use that closed profile section. If you hide one of them, it won't work. So as long as we've got them intersecting each other, we can use them as we want. But now what I'm going to do is take this and I'm going to mirror it to the other side across X. And now I've got sort of both sides of this hinge. Now, this hinge setup could be used on boxes or containers or whatever you want. And the big thing here is that we've got it sitting flat on the build plate. So we can use it in both a print in place orientation as well as printing each part individually. I will say that in terms of print in place, using straight lines, let's go ahead and only make a single line here. Using straight lines like this is going to be much better for 3D printing than to try to print these arcs here. Now, you don't have to do this, but if you want it to print a little nicer, especially at smaller sizes, when you're talking 5 to 10 millimeters, then having an angle like that or a taper up away from the build plate is going to be better than having a true arc in that section. For our purposes, I'm not really concerned with how it looks, but as you begin experimenting with these on your own, that's something that you should consider, is just kind of going up from the build plate at an angle, and you'll get a sort of a better or nicer, cleaner look to that 3D print. Okay, so now that we've got this, I'm going to take this and begin pulling it outward. I'm going to hit Tab on my keyboard, and what that does is it's going to lock the distances in both directions, and then I'm going to say +5 millimeters and Enter. Now, the reason I wanted to do that is because now I've got a 10 millimeter by 10 millimeter cylinder here. That's going to be the basis or the starting point. The next thing that I want to do is select this end face, hit E to extrude because we don't want to actually offset it. And I'm going to pull this out. And this is going to go as much as you want. It doesn't really need to be that big. We can make it 2.5 millimeters. I'm going to hit enter, but then I want to make sure that I use new body, which is B on the keyboard. That way it doesn't join it back to the original. Now, for right now, we'll just go ahead and hide it. We don't need to see it just yet. The next thing that we need to do is we need to take care of the taper in the center section. Now, there are a couple ways that we could do this. We could just select this face and hit E on the keyboard to extrude, pull that out, and change the taper to something like 45 degrees. That's perfectly fine. However, there's something that we should consider is that keeping this as the same body is going to produce problems for us later because the cylinder on the outside is going to have a knife edge where they meet. So we want to keep that in mind that we shouldn't necessarily just extrude from that face. We need to create a circle or something that's a bit smaller in order to make this work. Now we could do this as a new body, and I'll show you that example here. Let's go out a distance of, let's say 2 millimeters, and we'll hit B to make it a new body. And once it's a new body, then we can offset this face down and we can make it smaller. So if you want to go about it this way, let's say 0.5 millimeters, if you want to go about it that way, that's perfectly fine. If you want to do it a different way, then selecting this outside face, hitting the space bar, and then just simply drawing another circle and making it the same size. In this case, it'd be about 8.5 millimeters, and then extruding that out. That would be perfectly valid as well. It really just depends on how you want to control the dimensions and the way in which you want to work with your models. So what I'm going to do is take this, mirror it to the other side, this time about Y, not join it together just yet. But now we've got basically the pivot piece that's going to allow us to lock into the outside sections of our hinge. I'm going to take this section here. I'm going to begin pulling it out and hold down Control and snap to that edge. And once it's snapped to that edge, I'm going to hit Tab and then right click to accept. Then I can take this section here and hide it with H on the keyboard, or you can simply just click the eye icon over here. So now I'm going to take this and this one here, hit Q on the keyboard twice to join them together. These two pieces here on the outside, those are still separate. We'll deal with that in just a moment. But now what we have is the first or the starting point for our pivot. Now we need to address this piece here. When we're thinking about 3D printing, we have to consider tolerances, gaps, things that we need in order to make the parts actually work. If we're machining parts, we've got a much better control on tolerances, and we can deal with things like press fit or slip fit with very precise numbers. When we're 3D printing, we have to play it a little bit looser. When we're 3D printing these parts individually, we can make the tolerances a bit tighter because they can flex and bow, and it'll work that way. When we're printing them in place, however, the gaps in the tolerances need to be quite a bit bigger. So we're going to start with the first version as the individual pieces, and then we'll modify it to be a print in place. But the first thing that I want to do is I'm going to hide this, so H on the keyboard, is I want to have a small gap here. So what I'm going to do is I'm going to offset that inward, and we're going to use minus 0.125. So what that's going to do is it's going to give me a 0.125 gap between these two pieces. The next thing that we're going to do is we're going to remove this piece from this piece. So select the outside, hit Q, select this piece. However, we want to use T on the keyboard to keep the tool. Now the reason for that is because we can keep the tool and still remove it. That way we can join it back to that other piece a little bit later. We're not quite done yet. We have a 0.125 millimeter gap between this face and the face where it's going to meet our main pivot. But right now, this face and this face are perfectly matching. I'm going to leave the outside face exactly matching the location. And again, because we're printing these separately, we can do that. And that's a good way to control how tight the tolerance is, or how tight the joint is itself, and how well it stabilizes. But we can't have this piece be exactly the same. So I'm going to add a small gap, but not as big as that 0.125. So we're going to do minus 0.05. And what this does is it gives us a small gap between the pieces. We have a small gap between this face, a small gap between this face, and exactly matching with this one. So that's how we're going to get a nice tight joint. So what I want to do is hide that piece and sort of join everything together that I need. So Q on the keyboard, hold down Shift, hit Q again. Now we've got a single piece here. Then we'll bring this piece back and we're going to mirror it to the other side across Y. And now we need to build out the extra pieces here. Now this is where things get a little tricky. When we're working in plasticity and we're building off the center line, this right here is starting at that center line. And if we just start to pull it out, obviously that's not going to be the right size. So a couple ways that we can approach this is we've got a pivot point which we can change. So for example, if I say V on the keyboard and I set my pivot point, let's say right there, then I can extrude it. It's gonna flip out here. Let's start this over. I grab this here and V for pivot point. We can reset the pivot point over to this edge. However, one problem that this has is this is pulling in a direction that is sort of in line with that plane because of the orientation of that little triad that was there. So the way that we would want to do this is we can do freestyle, and we can start to extrude from here to here. And then we can move that entire solid object. So G on the keyboard, and then we can do freestyle F, and we can go from this point to that point. And that should be perfect. It should exactly match our overall size. There are other ways to do it, of course. We could move the sketch. We could create a new sketch on the outside of this face. And then when we're extruding it, we can hold down Control and we can snap to other geometry. But this is one way that we can do it. Next, I'm going to mirror this to the other side, again across Y. And I actually don't need to see this anymore, so H on the keyboard will hide that. And I want to join these all together. And the way that I'm going to do this is I'm going to start to sketch on this outside face by hitting space to create a temporary construction plane. And then I'm going to use my line tool and then come over here and just draw a vertical line. This is going to give me a closed profile. So if we rotate this around, as I'm starting to drag this out, hold down Control and snap to that edge. And with it still selected, we'll hit Q on the keyboard, hold down Shift, and hit Q again, and right click to accept. Then we'll get off our construction plane. So right now we've got a version of this that we can print that is going to be 2 individual pieces. I'm going to make a couple of other final modifications here. I'm going to add a small fillet to there. And generally when we're 3D printing, fillets are less than ideal. You probably want to use something like a chamfer in these edges. But for our purposes, it's going to be fine. I'm not using these in practice, and that's going to give us, we can see how it's going to deal with that curvature. But as I mentioned, in reality, when 3D printing, generally you want to use flat edges or tapers. That's going to give you a much better result. So 7 on the numpad, with both of these selected, we're going to duplicate it. That's this button here, or we can use Shift D, and then we're going to move the duplicate off to the side. Now the duplicate is going to be our 2 individual pieces. So I'm going to say INDV for individual pivot 1. And I'm going to do the same thing over here. Rename this INDV pivot 2. So those are going to get broken up when we 3D print. These ones, however, are going to be done as a print in place, but we need to add some more gap or tolerance. To really see what that looks like, we're going to hit C on the keyboard to cut. And I'm going to use this plane as a cutter. I'm going to go back to my target bodies, hold down Shift and select this one as well, then H on the keyboard to hide. So what we have here is, once again, if we zoom in, let's go ahead and zoom it down here. We've got the inside faces, these end faces, exactly matching. And then we've got the tapered faces. They have got a minus 0.05 gap, or a 0.05 gap between them. That's not nearly enough for us to consider this as print in place. If we tried to print this in place, even though it's 2 separate bodies, it would combine these together and you would just have one solid body. It wouldn't actually be a hinge. It would just be a piece. So we need to add some gap here. So let's Control Z to undo the cut. And let's take a look at leaving this piece as is, so H to hide. And then I'm going to select this outside face and shift select this outside face and say minus 0.125. Depending on your 3D printer, you'll have to play around and see what kind of gap you can actually get away with. I can get away with less than a 0.125 gap, but it is a little bit risky. So at 0.125, this should work okay. The next thing that we're going to do is offset these faces. Even though we've got a small gap, I'm going to do minus 0.125. And then if we bring the other body back, so this is going to be PIP for print in place 1 and PIP 2. Let's go ahead and cut this again. So C on the keyboard, go back to our target bodies, hold shift, and then H to hide. So now when we look at this, we've got that 0.175 gap between the taper and 0.125 gap on the end. That should be enough to get a small gap between the traces when we're 3D printing. So Control Z to undo, put those back together. And now it's time to export. So to export the print in place, we're going to select both of them, go to File, Export. We're going to select the format. I'm going to use STL in this case, and I'm going to call this PIP hinge. And I want to kick the density up to 1. Default is about 0.5. Because I'm dealing with so many rounded edges and tapers, I'm going to get the highest resolution possible, and then we'll let the slicer kind of deal with it. Next, we're going to export these individually. So export, and that was the hinge. I'll just call it hinge 1, right click, and we'll do the same thing for this one. We'll call this one hinge 2. Now we can bring those into a 3D print slicer and kind of deal with it from there. Now I'm using a Creality K1 Max. This is the same printer I used in the last couple of 3D print videos. And it's not perfect right now. I'm dealing with a small issue with some sort of binding on the x-axis, but for what we're doing here, it'll be just fine. So I need to go find those data sets, and we're just going to navigate to where I've got them. And we'll do the print in place one first. So got that one in place. Go ahead and bring hinge 1 in, and we'll bring hinge 2 in. Now you can certainly do this with smaller files or smaller size pieces, but one thing that you're going to find is with the smaller pieces, you're going to have to probably increase the tolerance more than you think. But the main thing that we want to focus on is that there is a gap between these two traces. And you can see there is a gap there, so I could theoretically make it a bit tighter. I'm using a default 0.4 millimeter nozzle, and the trace widths are, I think, 0.42, so all pretty standard numbers. If you are using larger nozzles or if you are tweaking those values, then just keep that in mind that when you're looking through the slice, you want to make sure that there is a gap there. So now that we can actually see a gap there, I'm going to go ahead and export this and 3D print it. So we can see that this one's going to take about 14.5 minutes. It's not too long for what we're doing here, but let's go ahead and print it, and then we'll take a look and see how they work. All right, so here we have the 3 versions right off the printer. Here's the print in place one. Of course, you need to actually tweak it and break it to get it to start moving, but it moves surprisingly well. Now, the joint itself is fairly tight right off the printer as soon as you break it, but if you take it apart, it's going to get looser. And that's one of the problems with these. If you have to disassemble it, then what ends up happening is the joint itself is going to be a little bit looser. Now, I will say that there are, of course, there are differences in the size of the tapered area. If you make those smaller, then it's a bit easier to assemble. If you change the depth or the taper area, then some of that's a bit easier to do. Now, the second version here, or really the first version we designed, this one was done as 2 pieces, so that it's a little bit of a tighter fit, which means you do need to flex it. This works better if the PLA is still warm, because then you're not permanently deforming it, but you will want to make sure that you do have those fillets on these inside corners. so that you don't have a big stress riser. But this one works pretty well as well. I mean, you can see that overall they're pretty much identical in terms of appearance, but the sort of slack between them is definitely different. Now, at this size, at 10 millimeters, it's not really that noticeable. Like, you could probably use either one and be perfectly fine. But again, I tend to sort of prefer to do the non-print in place version. I think that the geometry comes out a bit cleaner, but it does work in both cases. Now, that's going to be it for this video. I know this was just a simple example and we didn't design a real part, but hopefully you'll be able to apply this sort of print in place or printed style hinge to your own designs in Plasticity. If you have any questions, then please let me know, leave a comment. If you enjoy this content and want to see more, then please do subscribe and let me know what other content you'd like to see. As always, thanks for watching, and we'll see you in the next one.